Derivatives and equations of tangent lines. Recall that if y equals f of x is the function, then we have two notations for the derivative, either dy dx or f prime of x, where the derivative gives the instantaneous rate of change of the function at a point. In other words, the derivative is the slope of the tangent line. One big mistake a lot of my students make is that they call the derivative the equation of the tangent line. But the derivative is not the equation, it is only the slope of the tangent line. Let's write equations of tangent lines. And let's start with the function f of x equals 4x minus x squared. And we want to write the equation of the tangent line at x equals 1. Now, whenever you're writing lines, you need three things. You need the x, you need the y, and you need the slope. Now, you could have other things, but I like to say it this way. When you're writing the equation of a line, you need an x, you need a y, and you need a slope. So, I gave you x equals 1. I now need the y value to go along with it. So when x equals 1, y is 4 times 1 minus 1 squared, which is 3. So we now have the point 1, 3. So right about there. My picture's not drawn to scale, but it gives us an idea of what's going on. And we have a tangent line at that point. I want to write the equation of it. The only thing I'm missing is the slope. But we know that the slope is the derivative. So whenever you're finding a slope at a point, that is f prime, in this case at 1, take the derivative at x first, giving us 4 minus 2x, and then plug in the point x equals 1, giving us 4 minus 2, or 2. We now have a point, we have the slope, and we can write the equation of the tangent line. I like to put it in point-slope form, so y minus the y value equals the slope times x minus the x value. And that's the equation of the tangent line to the graph at x equals 1. Let's do a few more examples writing equations of tangent lines. What if our function is f of x equals 1 over x? And let's write the equation of the tangent line at, let's say, y equals 1/2. I have one of the three things that I need out of the y. I'm missing the x, so if I have 1/2 equals 1 over x, well, of course, x equals 2. So now I have the second thing. I got the x and the y. The only thing I'm missing is the slope, and the slope is our derivative. So let's find the derivative at x first. So the derivative of 1 over x is negative 1 over x squared. I'll show you on the side over here a reminder. So if I have the function is 1 over x, I could write that as x to the negative 1. And then we take the derivative, we bring the power down and multiply it, subtract 1, and then I rewrote it to make it look a little nicer. Now that we have the slope at x, we can find the slope at the particular x, in this case 2, which gives us the slope is negative 1/4. So I can write the equation of the tangent line now. I have the slope is negative 1/4. I have the point that it goes through is 2, 1/2. So the equation is y minus the y value equals the slope times x minus the x value. Another one. Consider f of x equals x cubed plus 2x. And let's write the equation of the tangent line. I'll abbreviate equation EQN of the tangent line. And let's do when f prime of x equals 5, and I'll add another condition, and x is negative. We'll see why in just a bit. So we need the x value, we need the y value, we need the slope. In this case, I gave you the slope as 5. So if I find the derivative, which is 3x squared plus 2, I can set this equal to 5 and solve for the x value. Going through this, we get 3x squared equals 3. And then x squared equals 1, or x equals plus or minus 1. And that's where this part comes into play. We're going to take the negative x value. I need the y that goes with it. So y is negative 1 cubed plus 2 times negative 1. So negative 3. And now we have the point, negative 1, negative 3. We have the slope is 5, and we can write the equation of the tangent line. So y minus the y value equals the slope times x minus the x value. And we have the equation of the tangent line. Let me do one more problem. I'm going to call this a challenge problem. It's one of my favorite problems to give my students when we're learning derivatives and tangent lines. So let g of x equal the following. The limit as h goes to 0 of 3 times x plus h to the 4th minus 2 times x plus h cubed minus, in parentheses, 3x to the 4th minus 2x cubed, and then all over h. And we want to write the equation of the tangent line, EQN again as equation, of the tangent line to g of x when x equals 1. All right, so why is this a tangent problem? Well, what does g of x equal? By this time, most students recognize that this back part is a derivative. And they go, great, let's find the derivative of this back function, which is absolutely correct. So we have 12x cubed minus 6x squared. But a lot of people say, well, that equals g prime because I took a derivative. But it doesn't equal g prime because I said g is all of this, meaning g is the derivative of this back piece. So that's going to be g of x. That is, this is my y value. So when x equals 1, we get y equals 12 minus 6, or 6. And now we need our slope, which is g prime of x. So we take the derivative of this, giving us 36x squared minus 12x. And then g prime at 1 is 36 minus 12, or 24. Then we can write the equation of the tangent line. Y minus the y value equals the slope times x minus the x value.